I think 7.4 is rather important. They want to know the names of two items of apparatus, instruments that are needed to measure accurate volumes of the acid and base in this titration. So how can you accurately measure the volume of the acid and the base? Which two instruments can you use in the laboratory? Well, you can actually use a burette. Yes, that instrument that's having something like a tap. So the burette will accurately measure the volume. But you can also use a pipette. There's another instrument which is called a pipette. Other people say it is a pipette, but I'm not sure. But yes, pipette. And there are many types of pipette. We have a pasture pipette. I know I'm not pronouncing pasture right. Yeah, it's rather funny when you write it out. So, hey, but just say pipette, you should be fine. Nevertheless, let's focus on the main thing. It is found that 40 milliliters of a 0.5 mole per cubic decimeter sodium hydroxide solution is needed to neutralize 20 milliliters of the vinegar. Okay. Do you know how many milliliters are there in 1 cubic centimeter? I'll see.
Can you please repeat the question?
Okay, the question is, do you know how many milliliters are there in 1 cubic centimeter?
Not thousand.
Okay, how many milliliters are there in 1 liter?
110.
Sorry?
I don't know.
You don't know.
100.
Okay. No, that's fine. I'll tell you later on. Remember what is the task here? They want to determine the percentage of ethanoic acid in a certain bottle of vinegar. And now they say to us, we are actually dealing with 20 milliliters of vinegar. And 20 milliliters is exactly the same as 20 centimeter cubed. That's how they relate to each other. Now they say we need to calculate the pH of the sodium hydroxide solution. It's not the pH of the final solution. It's just the pH of the sodium hydroxide solution. That is all. And it's just for 4 marks. So let's quickly destroy it. Well, we know the concentration of the sodium hydroxide as well as its volume. So we can find, we don't need to know the number of moles. No, we don't. Not by long shot. If we know the concentration, then it's all good. Because anyway, we know that sodium hydroxide produces the hydroxide ions when it dissociates in water, but it produces them in a 1:1 ratio, which means that the concentration of the hydroxide ions will be exactly equal to that of the sodium hydroxide solution. So since we know the concentration of this one, then we can just tell them that the concentration of the hydroxide ions is actually exactly the same as the concentration of the base itself. And this is just going to be equal to 0.5 mole per cubic decimeter. And the question is looking for the pH, but we know that it's very easy to find pOH firstly, and then take it to the pH. So we can now come and say pOH is the negative logarithm of the concentration of the hydroxide ions, which means it is the negative logarithm of 0.5. So when you take the negative log of this to 2 decimal places, you get 0.30. And you're actually allowed to take it to 2 decimal places here. Why? Because according to this relationship, you now have an integer, a whole number on the right-hand side. So it won't affect the final answer. No. Then if you now take your 0.3 to the right-hand side, you find that the pH of the solution will simply be 13.7. That is actually true because it's actually a basic solution. That's sodium hydroxide. So we are expecting the pH to be as high as possible. Now they say we need to calculate the percentage of ethanoic acid by mass, which is present in the vinegar. So when they say the percentage by mass, they mean we need to know the mass of ethanoic acid divided by the mass of this vinegar, and then we multiply it by 100. That's what they're saying. But listen to what they say. They're saying, assume that 1 milliliter of vinegar has a mass of 1 gram. So what does it mean? It means 20 milliliters of vinegar will have a mass of 20 grams. That's what they're saying. This question is almost identical to the one that I was writing when I was doing matric in the year 2020. I've already sent it to you, so yeah, I think you'll want to give it a good look. It's almost similar to that. They asked the percentage of vinegar as well. Or maybe they gave it to us. I'm not sure exactly, but I remember that it's similar to what I was writing. So now we know the mass of vinegar. Ours is just to find the mass of, sorry, I almost said sodium hydroxide. I wanted to say the mass of acetic acid. That's what we need to find. So, well, it's very easy to find the mass of acetic acid because we already know the concentration as well as the volume of the base. We can find the moles of the base and relate the moles of the base to the moles of the acid. Now that we know the moles of the acid, then we can easily find the mass of the acid. And over and out. But here we need to tell them that, well, is it sodium hydroxide? Of course it is. So this concentration is actually defined as the number of moles divided by the volume. And of course, the concentration here is 0.5 and the volume is 40 centimeter cubed. And if we divide that by 1,000, you properly get 0.04. Yes? Yes. And now when you cross multiply, you find that the number of moles of the base will simply be 0.02 moles. But now, according to this balanced reaction, we can see that the mole ratio is 1:1. So then this means the number of moles of the acid are exactly equal to those of the base. So now we know the moles of the acid, which is nice. Then now we can find the mass of the acid. So now we can say, well, the number of moles are actually defined as the mass divided by the molar mass. So then it's 0.02, which is equal to the mass. And what's the molar mass here? Well, we have 2 atoms of carbon, each with a molar mass of 12. We have 4 atoms of hydrogen, and we have 2 atoms of oxygen. So the molar mass is simply 60. And when you say 60 times 0.02, you find that the mass of this acetic acid, well, you can even specify, that's nice, is simply 1.2. And then you say grams. And now that you know the mass, then finding the percentage is a walk in a park. You can now say the percentage of this vinegar is actually equal to the mass divided by the mass of the entire. Did I say the percentage of vinegar? I wanted to say the percentage of acetic acid. Then we divide this by the mass of vinegar, which we know that it is 20 grams, because they said to us 1 cubic centimeter, 1 milliliter is actually 1 gram. So when you do that thing, you find that the percentage of acetic acid will be 6%. Math. Now they say to us the sodium ethanoate, which is the salt that is formed during this above neutralization reaction, it undergoes hydrolysis to form an alkaline solution. Now they want us to write down the equation for this hydrolysis reaction. Can you define hydrolysis, Ausi? What is hydrolysis?
So I'm not sure, but I know it has something to do with salt and water. It forms salt and water.
No, that's not hydrolysis. So hydrolysis is the reaction of the salt that is being formed as a result of the acid-base reaction with water. So when you take this sodium ethanoate and you dissolve it in water, it's going to produce 2 ions, the acetate ion as well as the sodium ions. the sodium ions will not react with water any further. They do not undergo hydrolysis, but these acetate ions, they do undergo hydrolysis. So we just take this acetate ion and we react it with water. And what is going to happen here? Well, easy. Water in this case is going to be an acid, and an acid is a proton donor. So this means the acetate ion actually gains a proton, and here we get the hydroxide ions. So it's always nice if you indicate the states or the phases. So you'll tell us that this one is an aqueous solution. Of course, it is an aqueous solution, even this, but water will be a pure liquid, and these ions are in solution. So we have an aqueous solution there. That is hydrolysis. It's the reaction of the ions of the salt with water.